So welcome back. Now we will discuss about the physical properties of amine. So let's clear out the board and start writing. Okay. Give the heading physical properties of amine. Okay. So write here physical properties of amine is already written. Okay, so what are the physical properties which we are going to learn here is, so give right here lower aliphatic amines are gaseous. Okay, so what you learn here is that lower aliphatic amines are gaseous and have fishy smell. So we have to remember this or memorize this as a fact-based thing. Okay, amines with more than 3 carbons are liquid. Clear? And amines with 8 to 10 carbons are solids. Okay. Now here if you want to add an important point, you can write that aniline is colorless but appears colored due to aerial oxidation. Aerial oxidation means with the atmospheric oxygen present in the atmosphere, the aniline is getting oxidized, and so it is imparting a specific color. So this was about the physical properties. You can copy it. Now we will move on to the basicity on the solvation and rest. So let's copy it. Done. After this, we have a property which is called the solubility. So give the heading solubility. So what is solubility? It's solubility. Yes, right. Solubility. Solubility means the ability to form hydrogen bonding and get soluble in water. As simple as that. So for solubility, if you see the structure of 1 degree amine, it is RNH2. For 2 degree amine, it is RNR and here H, and for 3 degree amine, RNR. Okay. So by seeing this, you can have an estimation that which is going to form more hydrogen bonding, because see a thing over here, since here is 2 hydrogen, it is having the ability to form 2 hydrogen bonds, right? This one, since this is having 1 hydrogen, so it is have a ability to form 1 hydrogen bond, and this one, it does not have any ability to form hydrogen bond, so 0. So what is the order? Order is 1 degree amine, 1 degree amine, or let's write amines. Okay, this is the order of solubility. So it is 1 degree greater than 2 degree greater than 3 degree. So this is the solubility order. So copy it up to this much. This was the end of the physical property. only this much is there. Otherwise, you can read your NCERT books. If you find any details, you can study. Next, we will learn about the chemical properties. Done. Now, in the chemical properties section, you have to remember that the main reactivity of the amine is due to the presence of the hydrogen, which is the RNH2, the hydrogen which is present, it is acidic, and the lone pair which is in the nitrogenous part, it can act as a strong nucleophile, or it can act as a strong base. Okay. So, keeping this thing in mind, we will now learn about the basic characters of amine. Now, basic characters mainly happen due to the presence of lone pair. Okay. Now, basic character, what do I mean by the basicity of amine? So, for learning that, you have to keep a reaction in mind or the hydrolysis of amine. So, let us see what is that going to say us. So copy it up to this much. Done. So, let us learn about the order of basicity. Right here, order of basicity of amine. Order of basicity. Base, I am sorry, this one is C. Please forgive me for my spelling mistakes. So, order of basicity of amine, for learning that, you have to remember that when you take RNH2, when you perform hydrolysis, okay, so what will you get from here? You will get RNH3 plus OH minus. Okay, now if you have studied in chemical equilibrium chapter, you should have remembered that Kb equal to RNH3 plus OH minus, and this one will be RNH2. Right, the hydrogen is getting multiplied over here, so this is becoming Kb. Now here, when you see a thing, when you increase the OH minus, the Kb increases, and if you take a log of this, that is a pKb, it is getting decreased. So, you have to remember this relation. So, in that case, in the question it may come which is having more Kb and which is having more pKb value, right. So, remember a fact that ammonia is less basic than amine. Clear? So, copy it up to this much. Now, we will come to the order of basicity. Now, we will determine the order of basicity. Now, for amine, when you study the order of basicity, you have to learn in two parts. Okay, the first part is in gaseous state, and the next part is in the liquid state. Okay, so for the first part, you have to notice the I effect. Okay, which is also called the plus I effect or the inductive effect. Okay, now what happens here is, if you see the structure of the 1 degree amine, it is like this, RNH2. Now, if you know what is basicity, basicity is the ability to donate this lone pair. Okay, and we know R is a pushing group, so I will push more this lone pair to move out and be basic. So, R is pushing here. So, here 1 degree amine, only one R is pushing. Okay, now if you compare in presence of R, N, R, and here is a H, sorry. Okay, so this both the R are exerting pull towards this lone pair to move out. This is 2 degree. Let's remove this, give the uniformity. Okay, and if you see tertiary, R, N, R, and here also R. Okay, now here you can see all the R's are pushing the N to donate the lone pair. So obviously, what is the most basic here? This one, which is 3 degree, okay, and this one. Now this thing is applicable both for gas and liquid state. Okay, this thing is applicable both for gaseous state as well as liquid state. What is happening? Because of more plus I effect in the 3 degree amine, the electron is more pushed or more probable to come out and be basic. The lone pair of electron is more probable to come out to become basic than the primary amine, which is also basic but less as compared to the 3 degree amine. Okay. The next property which we are going to learn is the solvation. Now, solvation is a property which is the ability to form hydrogen bond with water. So, clear it, I mean copy it down, next I will clear the board. Done. So, give the heading solvation. Now, solvation is only applicable for the liquid phase. So, give the heading solvation. Okay. Now, solvation is applicable only for the liquid phase. So, what happens for solvation when you take 1 degree amine? Okay, if you see the structure of 1 degree amine, how many H is present there? There are 3 H present, so the ability to form 3 hydrogen bonding obviously. So, for 1 degree amine, number of H bond, it is 3. For 2 degree amine, number of hydrogen bond is 2, and for 1 degree amine, the number of hydrogen bond is 1. So, obviously, the more the number of bond is formed, the more is the basicity. So, write here solvation direct proportional to basicity. Okay, so if this one is increasing, this one is also increasing. So, obviously, if you want to see the order here, here the order is becoming 1 degree is more basic than 2 degree is more better than 3 degree basic. But you have to remember that this is only for liquid phase. In the question they will mention which phase to notify while measuring the basicity. Okay, so note it down, this is the basis of solubility. Okay, now we will come on the basis of steric hindrance. So, it is obvious that the more the number of R group, the more is the steric hindrance, right. So, in steric hindrance on the basis of R group, if the group is big and all the group is or the group is small, you have two kinds of categories. Okay. Now, for steric hindrance, or you can write on R group, not write steric hindrance, write on R group. Now, this is a exceptional case. Okay. So, what happens here is, right here, if group is small, okay, then order becomes 2, 1, 3. If group is big, then the order will become 2 degree greater than 3 degree greater than 1 degree. Now, this is the order of basicity. Okay. Now, what is the meaning of big group? Big group can be C2H5 or like that, and small group means CH3 like that. So, this was all about the basicity of amine. I hope you have understood the things. If you have not any difficulty, just go through a reading of your NCERT book, you will answer it, or you can answer it very clearly. So, now let us come to the main part of the chemical properties, which is the reaction. So, clear it out. I will run this. Now, under the chemical reactions, if you remember, the first property which comes is the alkylation. So, give heading chemical properties. The first property which comes is the alkylation. Now, alkylation is already done in the method of preparation part. So, I am writing here already done, which is the Hoffman hemolysis C lecture 1. Okay. Now, second one is the acylation. Okay, acylation, ACYLATION, or the addition of a acyl group. Okay. So, what happens here is we take an amine which is C2H5, it is like this, C2H5N, and here a H, and here is also an H. I am writing the H like this. Okay. Now, let us take any acyl group. Let me assume CH3, C double bond O, and here is a Cl. Now, this O will take minus charge, so plus charge will be generated here, and the lone pair will go over here. Clear? Now, as a result of this, when this two will again do back bonding, this chlorine will move out, right? So, what is the end product which we are getting here is the end product which we are getting over here. If you write over here, so you get C2H5NH. Clear? And now this CH3, I am sorry, NH, C double bonded O, CH3. Clear? Just check it out. Clear up to this much? You can call it N, this can be N-ethyl, this can be called it N-ethyl ethanamide. Clear? So, this was all about the acylation, right? Next, we come to the important part or the name reaction, which is the carbylamine reaction, which is for the identification of the primary amine. So, copy it, I am going to clear. Clear? Okay. Give the heading carbylamine reaction or isocyanide test. So, carbylamine reaction, or you can write here isocyanide test for primary amine, because this reaction is only given by primary amine. So, what is happening here is we take a carbylamine reaction, we take any amine, okay, let that be RNH2, we treat it with CHCl3. Now, what is this? This is called chloroform, and you take potassium hydroxide. Now, as a result of this, see, carbylamine reaction or isocyanide test, that means you have to form an isocyanide. So, how does an isocyanide look? It looks like this, R N triple bonded C plus, as a byproduct you are getting 3 KCl, and obviously you are getting 3 H2O. Now, this thing has a fishy smell, which serves as a purpose of identification. So, if you get a fishy smell after performing this test, this is chloroform. Okay. So, if you after performing the carbylamine reaction, if you get a fishy smell, then it's proof that there is a primary amine. Okay. Now, there is also another process for the identification of 1 degree, 2 degree, 3 degree amine, which is the Hinsberg test, which we are going to deal with in the later sections of this lecture. So, copy it, I am going to erase it. Done? So let's clear it out. Now we are going to do the Hinsberg test. Okay, so Hinsberg test, we perform it with aryl sulfonyl chloride, which is also called the Hinsberg reagent. So write the formula: reaction with aryl sulfonyl chloride. Okay, and this aryl sulfonyl chloride, it is also called Hinsberg reagent. Clear? Aryl sulfonyl chloride is also called the Hinsberg reagent. So what is, or the how does the Hinsberg reagent look like? It is like this: C6H5, this is the aryl group, this is S double bond O, S double bond O, and here is Cl. This is the structure of aryl sulfonyl chloride or the Hinsberg reagent. Clear? So copy it up to this much. I will be back in a while, just 30 seconds. I have to refill my black ink. Just a minute. Now in the Hinsberg test, after reacting the amine with the aryl sulfonyl chloride, if in the Hinsberg test, we first react the amine, we don't know what it is, we react the amine with aryl sulfonyl chloride. Now after that a complexing reagent is formed. Now if that reacts with NaOH, it is primary, if not then it is secondary, and or it can be tertiary. I am explaining it one by one. I am done with my refilling. So let's continue. Okay, ready? So let's begin. We are going to learn about the Hinsberg test. So let's make some space. Give heading Hinsberg test. Hinsberg test. Clear? So what happens in the Hinsberg test? We take any amine. Let us assume primary amine in the first case. So 1 degree amine, or we take do directly. Okay, so RNH2 plus C6H5, S double bond O, S double bond O, and Cl. So S is getting a positive charge over here because of the highly electronegative pool of the oxygen. So what happens, this oxygen, nitrogen is attacking here, this opens up bonding, and this also opens up bonding. So as a result of which the Cl is moving out. Now what happens to the Cl is, let me see. Okay, so the net reaction which is forming is C6H5. Here it is coming S36H5, S double bond O, N, and next this R group is coming. H, and this R group is coming. Now if you can see here, nitrogen is forming 4 bonds, so naturally a plus charge is being generated. So what happens, this hydrogen is giving the charge and it is escaping with this Cl minus. So what we are getting at last is this HCl is coming out. Okay, this HCl is coming out. So what we are getting here is, we are getting C6H5, S double bond O, NH NHR. Clear? Now when you again react this with NaOH, what happens? This H is getting replaced and as a result we get this C6H5S double bond O, here N, this becomes Na, and here is the alkyl group, and this thing is a soluble salt. If this becomes soluble, then it's a proof that, or an identification of a primary amine. This is 1 degree amine. So this was all about the Hinsberg test. Now in case of primary amine, here it will be R in H R, right? This thing will remain same, this nitrogen will attack in the same thing. Let's do it 2 degree amine. Same thing will happen, but in case of this H will not be there. So as a result, this plus charge will be nullified by this hydrogen, clear, and this is coming out as HCl, right? Now here this is the ultimate structure which is formed. This is the ultimate structure which is formed. Now when you react it with NaOH, we get just nothing. Why we get nothing? Because there is no hydrogen, right? So we just don't get nothing. So you have to write, for Hinsberg test, the 2 degree amine will react with aryl sulfonyl chloride, but it does not react with NaOH. So it's a proof that it's a 2 degree amine. Now if it reacts with NaOH, then it is a proof that it is a 1 degree amine. Now but for 3 degree amine, okay, now if this is 3 degree amine, same thing will not happen, nothing will happen, because in case of 3 degree amine, you will have another R group over here. I am drawing this for reference, okay. Another R group is there. Now where is the, now when this nitrogen will attack, okay, and this bond will open up, this bond will close, Cl will go, okay. Now if you see here, here there is R, here there is R, and there is a plus charge which is unstable, right? Now here if you see, there is no hydrogen for the nullification of the plus charge, so this reaction cannot occur. So this is not stable, right? So this is not stable, so I am putting across. So you have to write that 3 degree amines do not react with aryl sulfonyl chloride or the Hinsberg reagent. Okay, so let's sum up. If the aryl sulfonyl chloride or the Hinsberg reagent reacts with the amine and also with the NaOH, it is the primary amine. If it does not react with NaOH, it is the 2 degree amine. If it does not even react with the aryl sulfonyl chloride, it is the 3 degree amine. Okay, so let's move on to the another section. This was all about the Hinsberg test for the number of amine. Now we will study the electrophilic substitution of amine. Okay, so give heading electrophilic substitution of amine. Okay, electrophilic substitution. Okay, now I have to remember that amines are highly, what you say, amines are highly susceptible, or the NH2 group in the amines are highly orthopara directing group, and plus C substitution occurs, or the electrophilic substitution occurs at the ortho and para positions. We will understand this. What is the ortho and the para position? Now if this is your aniline, okay, if this is your aniline, this is aniline, this is the ortho position, this is the meta position, this is the para position. Similarly, this is the meta position and this is the ortho position. Now this NH2 group is a ortho and para directing group. Clear up to this much? Only this much knowledge you understand, and now I am doing the bromination. Okay, so copy it, copied, done. Give the heading bromination. Okay, bromination. Okay, now your amines are very much reactive towards electrophilic substitution. So what happens is, when you take aniline, this is aniline, when you react it with bromine water, what you get? You get 2,4,6 trinitro tribromoaniline, sorry, this is 2, 1, 2, 3, 4, 6. Now, why this is happening? This is because due to high reactivity of aniline. Now, in the question, if they ask you, we want mono substitution or we want only the para product. Okay. So, what you have to do? You have to do a process which is called the protection of aniline. So, for that, what you have to do? I am just showing you. Okay. So, copy it and we come in. Done. So, let us perform the protection of aniline or the mono substitution. So, for mono substitution, what we do is first we make the NH2 group a bit bulky, so that due to steric hindrance the bromination does not occur. So, this is my aniline. So, bromination you gave heading mono substitution. Okay. So, bromination mono substitution, this is the aniline. We now perform the mono substitution by alkylation. Okay. So, CH3, C double bond O, CH3. So, this will move and this will move, this will come out. So, as a result, thing which we will get here is this one, NH C double bond O, CH3. So, what happens are this bulky group, this is a bulky group, right? This is the bulky group. So, this position cannot be attacked because this is becoming very crowdy over here. That is called the steric crowding. Okay. So, now if you perform the bromination, when you perform bromination, what you get here is something just like this, NH2. I'm sorry. When you perform bromination, you get like this. You get bromination. Now, my purpose was mono substitution, that means I have to remove this alkyl group, right? So, if you perform here with the hydrolysis H plus or OH minus, then this part will get removed and you get the aniline back. So, this is metabromo aniline, I am sorry, parabromo aniline. This is NH2 and here is aniline. Clear up to this much? So, this process is called the protection of aniline. Clear? Now, the same thing you have for the nitration of aniline. Please copy it down. I am giving it. Done. So, let us see about the nitration. So, nitration, right? So, nitration. Nitration. So, this is my aniline. Nitration is a peculiar case, please try to remember it. Okay. So, this is nitration I am performing, this is my aniline NH2. So, for nitration you have to react it with H2SO4 HNO3, H2SO4 HNO3. So, what happens here is you get two peculiar things or three products you are getting rather. Okay. So, what you get here is like this. This is ortho, this is para, this is ortho, and this is meta, and this is the ortho product. Now, there are some percentage of the majority which is formed. So, meta is formed 47%. Okay. The para is formed 51%, and this ortho is formed 2%. Okay. Now, why this happens is because of resonance effect, inductive effect, and also the mesomeric effect. Okay. So, again if they ask you to perform the mono substitution, now you have to do the same thing, which is the protection of aniline. How aniline is protected? By alkylation. So, let us do it. So, write heading alkylation of aniline. So, nitration by protection. or you can write nitration monosubstitution. Okay, mono substitution. So what happens? Again the same thing, I am doing a step jump, not showing the entire thing, it is already shown. You take CH3, C double bond O, Cl. I am taking chlorine in this case, not CH3. Okay. So what happens here is this H will get removed. So as a result of this one, so a structure like this is coming. Now this is bulky, so this area will get sterically crowded. So when you perform nitration, nitration, H2SO4 plus HNO3, when you perform, you get only monosubstitution. So what happens here is like this, NH, C double bond O, CH3, and nitro group will get attached over here. So when you perform the H plus OH minus hydrolysis, this entire thing will get removed, and so you get your paranitro aniline. So NO2, this is NH2. Clear? So copy it down. Let's see if we have something left. Okay, we have the last thing which is left, which is the sulfonation or the formation of the Zwitter ion. So if that is done, the chemical properties of the aniline part is done. Next we have the diazonium salts, which will come in the next video. Okay, so copy it down. Done. So let's learn about sulfonation. Right, sulfonation. Sulfonation. What happens in sulfonation? Let's see. Okay, what happens in sulfonation? Now this is the aniline group. Now this is the aniline. When you treat it with concentrated H2SO4, remember it, concentrated H2SO4, what happens here is a complex type thing will form, which is the like this, which is also called the sulfonalic benzene. This is NH3 plus SO4 minus. I'm sorry, this will be HSO4. Very sorry, this will be HSO4 minus. Clear? Clear? Now, if you treat it with heat, H2O, at a very high temperature of 483 Kelvin. Okay. Now, what happens here is H2 is eliminated. Right? I'm sorry, you are not treating with it H2, you are just heating it at a very high temperature, which is 483 Kelvin. So for that, the hydrogen or the water is getting eliminated from this. So what we are getting is called the sulfonalic acid. So let's see how it is looking like. A type of rearrangement occur. So it looks like this, NH3 plus and SO4, I'm sorry, HSO3 minus. Let's make it a bit clear. This is NH3 plus and HSO3 minus. Clear? I'm sorry, this will be NH2 plus charge will come just now. Okay. Now a type of rearrangement occur. Now the H will come here. So this H will have a tendency to go there. So what happens here is this becomes NH3 plus and SO3 minus. Now this entire thing is called Zwitter ionic form. Clear? This is called the zwitterionic form, and this is called sulfonalic acid. Clear? Clear up to this much? So let's clear out the board. So this was all about amines. In the next video, we will discuss about the formation, means the method of preparation, chemical properties and compounds of the benzene diazonium chloride, which is a very important thing, or the diazotization. We will discuss the mechanism of diazotization, formation of compound like the phenol, lead, ethylene blue, methylene, like that. So keep studying. All the very best.